So here is a question. Okay. So a sand layer found at the sea floor under 20-meter water depth is categorized by relative density of 40%. Okay. Maximum void ratio is 1. Minimum void ratio is 0.5. Specific gravity of soil solid is 2.67. Assume the specific gravity of sea water to be 1.03 and unit weight of fresh water to be 9.81 kilonewton per meter cube. So what would be the effective stress at 30-meter depth into the sand layer? Now what would be the change in effective stress at 30-meter depth into the sand layer if the sea water level permanently rises by 2 meters? So we have to note down what are the values given in the questions. Okay, so we have a water table here, okay, on the surface layer, sorry, yeah, and then 20-meter depth, water depth. Okay, so we have a 20-meter water depth here. So here what gamma sea water is given as 10.1043. Okay, that is calculated. So then what do you have to find? Gamma sat is given. Okay, is it given? No, we have to find out. Okay, so ground level, it's a sea bed here. So 20-meter depth. Okay, what you have to find out? What would be the effective stress at 30-meter depth into the sand layer? Into the sand layer, right? So it is after sand layer. Here is the sand layer here. So we have to take 30-meter depth here. Okay. So what are given here? We are given relative density is 40%, maximum void ratio, minimum void ratio is given. Okay. So what is the unit weight of seawater? So we have density is given, right? It is given as specific gravity is given as 1.03 divided by gamma W. Okay, gamma seawater divided by gamma water is equal to 1.03, which is then taken as 1.03 into 9.81. So the unit weight of seawater 10.1043. That's how you get it. So gamma sat is calculated as G plus 1 G plus E multiplied by gamma W. Gamma W is it is seawater, right? So gamma SW divided by 1 plus E. So you need to find gamma sat here as it is the value is not given. So what is the relative density? So ID is equal to E max minus E divided by E max minus E minimum. Okay, so relative density is shown in module 2. Okay, so the most important aggregate property of a cohesionless soil is the relative density, and it is known as relative density index. So it is given by dr is equal to E max minus E divided by E max minus E minimum into 100. So E max is the maximum void ratio of the soil in loosest condition. Okay, whereas E minimum is the minimum void ratio of soil in densest condition. So E is the void ratio in natural state. Okay, you have to remember this equation E max minus E divided by E max minus E minimum. The relative density of soil gives more clear idea of the denseness than does the void ratio. Okay, relative density gives the denseness of soil than the void ratio gives. The relative density of soil indicates how it would behave under loads. Okay, the deposit in is dense, it can take heavy loads, right? If the soil is denser, then it can take heavier loads with very little settlement. Okay, so depending upon the relative density, the soil are generally divided in 5 categories. That is very loose soil, medium dense soil, dense, very dense. So you have respective values for DR. Okay. Okay, so the equation is given ID equal to E max minus E divided by E max minus E minimum. So ID is already given. ID is 40%, 0.5. So we have 0.4 is equal to E max is given, right, as 1. 1 minus E divided by 1 minus what is 0.5, that is the minimum void ratio. So we get value of E. Okay, we got the value. So gamma saturated, you can calculate gamma saturated as 2.67 plus, okay, you got E as 0.8 divided by 1 plus 0.8 multiplied 10.1043, that is unit weight of seawater. Right, you get gamma sat, that is 19.47. Okay, then effective stress at 30-meter depth into the sand layer. Okay, so it was given in the question that there's a ground level, so here is the sand layer, so below, so 30-meter depth. Okay, what would be the effective stress at 30-meter depth into the sand layer? Okay, so effective stress equal to sigma minus u, so sigma is equal to 20 into gamma is w plus 30 into gamma sat, right? So how you get it? So you get it as total stress is equal to 7787.023 kilonewton per meter square. Okay. So what do you get U? How do you calculate it? U is gamma SW. So you take it for the gamma SW multiplied by 20 plus 30. Right. Yeah. So you get value as 505.215 kilonewton per meter square. Then effective stress equal to 787.02 minus 505.215. So you get answer 281.80 kilonewton per meter square. So if the sea level water level rises by 2 meter, the effective stress will not change at any layer below the bed level. So below the bed level, so there will be no change in effective stress even though the sea level increases to whatever height they are mentioned. Okay, that is one of the important question. Okay.